process the steps. I want to remind you guys that up on Classroom, it's been there all year, all the how-to videos. All right, it's right above the start of the school year info, right there, construction help. All right, to find what you need to go step by step. All right, so it's always there for you. All right, first step, first one, how do I construct a tangent line? Quick vocab quiz now. What's a tangent again? A line that intersects the circle one spot only. And that spot in this case is going to be point P. So I want a tangent line, not just freehand-it. All right, don't grab your straight edge and just draw it in. I want a tangent line that goes through point P. All right, first step. I want to I'll write down these steps as we go along here. First step, make an extended radius through point P. Make an extended radius through P. Extended radius, so just don't stop at P. Go right all the way through there with your straight edge. Extended radius through P. Go ahead. Then I'm going to use one of our circle facts to do the rest. We're going to use a circle fact to do the rest of it. When we have this tangent drawn in at the end, what am I going to know about the radius and the tangent? They're going to be, remember that? Radius drawn to a point of tangency forms a right angle. So here's what we're going to construct. And we've done it already in the past. I don't know when, it's been forever, but we've done this. We are going to make a perpendicular line to the radius, but going through point P. That's what we're going to make right now. A perpendicular line going through P and perpendicular to the radius. So we're going to construct a perpendicular line through P. And that's all I'm going to put for the steps. That's what we're going to do, construct a perpendicular line through P. Put your compass point on P. And I need you to make an arc. Above, below, I don't care. But that arc's got to intersect your extended radius in 2 spots. Okay, so make an arc that intersects your, coming from point P, make an arc that intersects your extended radius, not in 1, but 2 spots. 2 spots. And remember, just a reminder what we've been talking about, trying to talk about all year. Try to make small arcs. All right, the bigger you make them, the more points of intersection you have, and you get confused. All right, so don't make these huge arcs here. Try to make them as small as possible. All right, go ahead, keep going. I'm going to slow down. Mark those 2 points where it hit your extended radius. I want you to mark those 2 points because that's where we're going to put our compass in the next 2 steps. All right, that's why we made this arc. So now I know where to put my compass in the next 2 steps. Here and here. So you already know where we're going in the next 2 steps. Open up your compass just slightly wider. The reason? You need something to line point P up with, and my fear is when you make an arc, when you make your next 2 arcs, it's going to look like this and land there. Where the heck am I going to line everything up with then? So that's why I want it opened up a little more. All right, put your compass on 1 point. Put your compass on 1 point. And you're going to make an arc again, above or below. I don't care if it intersects the first one. I prefer it doesn't, so it doesn't confuse you. All right, so go to 1 point of intersection, make an arc. Again, this can be done above or below your radius. And you already should know where you're going with your next, right? The next step, where you're going to put your compass, because that's why we made those 2 points of intersection. So go to the other point and make it intersect the previous arc. Both arcs you make from your points should intersect each other. Okay? Both arcs you make from each point of intersection should intersect each other. And now you're going to draw in a line that is perpendicular through your radius through point P, which guarantees us it's got to be a tangent. Because the only way it's perpendicular is if a tangent and radius meet. So that line has to be a tangent line. Questions? A tangent to a circle. Extended radius, perpendicular line. Good? All right, what's next up? Put a square in this circle. Put a square in there. That's what I need. Not just any square, inscribed, which means, just let me show you. You're not, and please don't do this because it's incorrect. I'm not using a compass to do this. If it's inscribed, you can't look like that. Why not? It's got to touch, right? All four vertices got to touch. So it's got to look like that at the end, or some version of that. All right. All right. Look, I'm not a big fan of telling you the steps. I want you to understand where everything's coming from. What do you know about a square? Oh, okay, that's everything that everyone knows that, right? All four sides equal. All right, so if all four sides are equal, can you call them something else other than sides? Because now we're in a circle. Those aren't sides. Those are what? Oh, so I need four congruent chords. And I think we learned this unit. If I need chords congruent, what should be congruent first? The four arcs, right? If you have four congruent arcs, that means their chords are congruent. So that's our goal right now. Help me get four congruent arcs right now on this circle I've provided you. Get me four congruent arcs. If you can do that, you'll have four congruent chords. So how do I get four? And I just say, hey, don't, oh, hey, whoa, sorry. Don't be oh, hey, there you go. There's four. It looks congruent. No, we're not doing that. We're not doing that. I need four congruent arcs. It's four. Let me back it up. Let me make things a little easier. Can you get me two? I know four is asking a lot. How about two? Let's start with two. Can you give me two congruent arcs? Yeah, grab your straight edge and draw on a what? Yeah, there you go. Grab your straight edge, draw on a diameter. That cuts it into two equal arcs, right? Good job, kids. Whew. All right, I got two. I need four, though. A couple suggestions that came up in my first period class was make another diameter. Oh, I got an issue with that. All right, how about I make that diameter there? Those arcs are congruent. Can't just draw in a random second diameter and now they're all equal. Nope, can't do that. All right, how can I make these two congruent arcs into four congruent arcs now? What's up? What do you think there, Dylan?
Draw a perpendicular line that goes through the center.
I'm going to bisect this. All right, so you take your diameter and we're going to bisect it using our compass. That's the one everyone remembers. Ready? Take your compass, put it on one endpoint, open it up. More than half the length. Make a decent size arc, right? Keep your compass open the same opening. Head on over to the other point of intersection. And hopefully when you line the 2 points of intersection up, your center is included there as well. All right, hopefully your center is included when you line up those 2 points of intersection. And again, I want to keep talking circles here. All these angles are what here? If that's a perpendicular bisector, all these angles are what? Right at 90 right angles. And in the circle, what did we call those angles that come from the center? Central angles always equal to its arc, right? So if these are all 90, so are the arcs. Guaranteed congruent. Last thing I need to do, where's my chords? All right, I need 4 congruent. Now that I got 4 congruent arcs, where's my chords? Where's my chords here? Grab your straight edge, right? Connect them. Boom. 1, 2, 3, 4. Let's make that inscribed square. We guaranteed that all 4 arcs are congruent. They're all 90. There is your inscribed square, everybody. Inscribed square. And I love this, and I know you don't because it has to do with some math and circles, but I'm going to keep grinding with the circle facts. What else do you know about a square other than all 4 sides equal? What's usually the next thing you say? All the angles are congruent, and they're all what degree measure? How are you guaranteed that that angle right here, for instance, is 90 degrees? What type of angle is it in the circle? Isn't that inscribed? And where's it drawn to? Everyone see that? Inscribed angle drawn to a diameter has to be a right angle. Okay? So steps real quick so you don't forget. What was the first thing we did before we even picked up a compass? Draw a diameter. That cut it up into 2. Then what do we do to the diameter? It's only 2 steps. We bisect the diameter. Yep. There you go. It's only 2 steps. Draw a diameter, bisect it. Tangent, square, we're all good so far? Oh, I love these next 2. Love these next 2. All right, you can put a square in there. How about we throw a hexagon in there now? How many sides, hexagon? Quick reminder. 6 sides. So square, you told me I needed 4 congruent chords. That would mean 4 arcs. So now you're telling me I need 6 congruent chords, which would mean 6 congruent arcs. How do I make 6? Geez, I just had a tough time doing 4. How do I make 6 congruent arcs? All right, I'm going to help you draw a radius in. Here we go. Not an extended one, please. Just a radius. Take your straight edge, draw a radius in. Make sure you mark the point where it hits the circle, please. All right, so coming from center T. Mark that point, please, where it intersected. Measure the radius with your compass. Measure the radius with your compass. So we draw a radius, measure it with your compass. So everyone right now, your compass should be open to the length of your radius. And I'm going to do it with you. What we're about to do is we're going to go around the circle, making arcs that are the same length as our radius. Every arc up here should be the same length as your radius. So put your first compass point on where the radius intersected the circle. And what we're going to do is we're just going to make a arc through the circle right there. So this arc should be the same length as your radius. Let's keep going around the circle until we get 6 arcs that are the length of your radius. So everyone now put it on this point of intersection here and make another arc along the circle. Your goal is to get 6 of these, which will all be congruent to each other. Okay, I have 1, 2. Let's keep going around the circle. 3. 4. And now here comes 5 and 6. Good. I see a lot of you. That's nice. You don't have to, but I see a lot of you marking the point where they all intersect the circle. And now we draw our chord. Now I have 6 arcs, 6 chords. 6 arcs, 6 chords. So let's see, draw radius, measure radius with the compass. Construct 6 arcs that are the length of the radius. Nice. You guys can do a square, you can do a hexagon, and to finish today off, I'll let you guys finish off that hexagon that are still working. Now we're going to do an equilateral triangle. And I am not going to teach you a thing. Think about the last 2 constructions we've done. What do you know about an equilateral triangle?
All sides are equal.
All sides are equal, which means all 3 what have to be equal in the circle? Arcs, so I can get 3 chords. You've done 4 congruent arcs. We just did 6 congruent arcs. Now I'm asking for 3. Ooh. I'm asking, how can I get 3 congruent arcs? Is that possible? We know how to go from 2 to 4 to 6. Now we got an odd number. How do I get 3 congruent arcs? It's a rough life here. Darn right we can. Okay, I'll give you another hint. We've done it already. What is he talking about, right? You know how to get 3 congruent arcs. We've done it. And why am I showing the hexagon construction too? Anybody know where we're going here? This is not a fourth new construction. Same steps as we did here, but how do I get 3 congruent arcs? You know how to get 6 by doing this method. How do I get 3 out of it then? What's that? What? What's the diameter? Diameter is going to get you 2. Right? I want to use this construction. So after you're done, you have 6 congruent arc marks. You have 6 congruent arcs, but I want 3. How's that going to happen? Connect. What do you mean? Okay, I connect 3, but I just don't want to, I don't want to connect the first 3. Every other one. There we go, right? Take your 6 arcs, and take a look. I'll just do it on mine real quick. Take your 6 arcs, connect every other one. These 2 added together equal those 2 added together equal the final 2 added together. So I only showed you 3 new constructions today. Hexagon and equilateral triangle are the same ones. So go around, find your 6 congruent arcs, and yes, connect every other one now. Connect every other one. So if you do need to make a list of directions here, step 1, hexagon construction. Number 2, connect every other arc. And there it is. All right, I have 2 constructions tonight. I appreciate it. Do not pack up. Do not pack up after you're done with those. Go right to the review for the quiz on Tuesday, all right, which is on the next page. All right, continue on to the review on the next page for me, please. Answer key is in the back as you complete those problems.